Have you ever felt stupid in a math class? Not because you are lazy. Not because you cannot learn. But because the teacher used symbols nobody explained. And spoke like you were supposed to already know. That feeling is not your fault. Most people are never told what calculus actually is. They are just handed formulas and told to memorize. And then they think, I am not a math person. That is a lie. There is no such thing as a math person. There are only people who are explained clearly, and people who are not. By the end of this video, you will understand one of the biggest ideas in human history. And a child could understand it. Because calculus is not complicated. It was just never explained simply. Let me fix that right now. Drop a ball from a bridge. It falls. Faster. Faster. At 1 second, 10 meters per second. At 2 seconds, 20. At 3 seconds, 30. The speed never stops changing. Now here is the question that broke math for 2,000 years. At exactly 1.5 seconds. Not before. Not after. How fast is the ball going? Here is the problem. Speed needs two things: distance and time. But a single moment has zero time. Zero distance. Zero time. 0 divided by 0. That is not a number. That is a dead end. Normal math says, I cannot help you. That is where calculus comes in. Not because calculus is hard. Because normal math was never built for things that change. So two people asked a different question. Not, how do we fix the old math? But what if we invent a new math just for change? They called it calculus. In the next few minutes, you will understand how it works. No formulas, just the idea. Let us keep going. Every changing thing asks two questions. How fast right now? And how much total? That is all of calculus. Let us look at the first question. How fast something is changing at one exact moment. That is called the derivative. You already saw this with the falling ball. At 1.5 seconds. How fast was it going? Not the average. The exact speed right then. That is what a derivative tells you. Now, the second question. How much total change happened? That is called the integral. We will get to that in a moment. First, let me show you how the derivative works. Remember our falling ball. Frozen at exactly 1.5 seconds. Zero distance. Zero time. Speed impossible. But here is the trick. Instead of one frozen moment, measure a tiny split second. Then make it smaller. And smaller. And smaller. Watch what happens. The speed approaches a single number. 15 meters per second. That approaching number has a name. It is called a limit. A limit is just the value something is heading toward. Not where it is going. And that limit? That is the derivative. Now, what about the second question? How much total change happened? This is called the integral. Think of your car. You have two main gauges. Your speedometer tells you how fast you are going right now. That is the derivative. But your odometer, the trip meter, tells you how much total distance you traveled. That is the integral. Now, Imagine your trip meter is broken, but you have a recording of your speedometer for the whole trip. How do you calculate your total distance? Normally, distance is just speed multiplied by time. If you drove at 60 for 1 hour, you went 60 miles. Easy. But what if you were constantly speeding up, slowing down, and stopping? There is no single speed to multiply by. Normal math gets stuck. So calculus does something beautiful. It breaks your trip down into tiny 1-second intervals. In 1 single second, your speed barely changes. So you can easily calculate how far you went in that 1 second. Maybe 15 meters. Then, you just add up the distance from every single second of the trip. By adding up all those tiny, split-second distances, you get the exact total distance of your trip. This process of adding up tiny slices is the integral. And the symbol for the integral, this beautiful, long curve, is literally just a stretched-out letter S. It stands for sum. But wait. If the derivative gives you speed at each moment, and the integral adds up those moments to get total distance, then they are opposites. That is the fundamental theorem of calculus. Derivative slices. Integral glues. Two sides of the same coin. Now you understand calculus. Once you see this connection, you start noticing it everywhere. And it's much simpler than you think. Take a simple bathtub. The speed of the water flowing from the faucet right now, say, 0.5 liter per second, is a derivative. If you twist the tap, that speed changes. Simple. Or watch a shoot of bamboo. The speed it grows each day. Rapid in the warm spring, slower in the winter, is the derivative. But the total height? That is the integral. Just the sum of all those individual days of growth, added together. Derivatives break change into pieces. Integrals glue them back together. And that is the secret language of a changing universe. For more real-world problems, check out our other videos. We made dedicated videos for each individual topic, so you can dive deeper. Thanks for watching. Make sure to subscribe, and I will see you in the next one.